Before we do question number 37, I just want to remind you of a property of the infinite geometric series substitution. So when we have the infinite geometric series, a power series basically, okay, we have this formula S, the sum of the infinite geometric sequence is 1 over 1 minus x. And we could do substitutions into the brackets there, and whatever we put into that bracket, so we're going to put into the formula of 1 minus 1 over 1 minus x. Okay, so we're going to use that at some point. Just a reminder of this is something that we probably did in previous lessons. Okay, so here we've been given a function f. It's defined by 1 plus 2x plus x squared. So for n starting at 0, all the even terms have a coefficient of 1, and all the odd terms have a coefficient of 2. Now to come up with one formula, it's a little bit one series formula, because we're going to have to find the interval of convergence. We need a series formula, and to come up with one series formula is a little bit difficult. So I'm just going to split it up into two parts. All the terms with coefficients of 1 and all the terms with coefficients of 2. So the coefficients of 1 all have a predictable formula. They go up by even powers, and the coefficients of 2 go up by odd powers. So we're going to come up with a series formula for each of those separately. So really this is just x squared to the power n into our series formula, and it simplifies to n equals 0 to infinity of x to the 2n. Now we can use that for part of our series formula, which we could then put into a ratio test, which we need for the interval of convergence. We need a series formula for the other part as well. And for the green part, they all have a coefficient of 2, and they are odd powers. So we're going to write it as 2n plus 1. Okay, so we have the function described with two series parts. We can put them together, we can put them back together, and it's going to look like this. So the series from n equals 0 to infinity of x to the 2n plus the series from n equals 0 to infinity of 2x to the 2n plus 1. So having this function, we can put this together and apply the ratio test to this. X to the 2n plus 2x to the 2n plus 1. So applying my ratio test for the interval of convergence, I have a limit as n approaches infinity of the numerator term, I'll do in blue here, is going to be x to the power 2n plus 2, because we substitute plus 1 into the brackets, into 2n, plus 2x to the power 2n plus, when I substitute plus 1 into there, I get 2n plus 2 plus 1, or plus 3. Okay, so that's my n plus 1 expression. In the denominator, I'm just going to use, maybe I'll just use green here. This is going to be the n expression, or maybe I'll do it in black. X to the power 2n plus 2x to the power 2n plus 1. I need that to be less than 1. Okay, so I need to simplify this expression before I apply my limit. Since I have a common factor of x to the 2n, this common factor applies in every one of those terms. I'm going to divide out by x to the power 2n. So my expression is now going to look like this. I'm going to be left with x squared plus 2x to the power, the 2n divides out, so I'm left with cube. In the denominator, I'm left with 1 plus 2x to the power 1. Okay, now this is going to be a little bit hard to apply limit to because I no longer have n, first of all, and I have got just x's here, so I need to simplify this out before I evaluate my interval of convergence. And to do that, I can just factor out an x squared, and I end up with 1 plus 2x in the numerator. In the denominator, I have 1 plus 2x. Those will cancel out. And I'm just going to drop my limit notation because I no longer have any n's in there. And I can work out my radius of convergence. I get x squared is less than 1. So my radius of convergence is 1. And my interval convergence, when I solve all that, becomes from 1, -1 to 1. Okay, so then I need to test my endpoint for this. So this is my, I'm going to write it in proper interval notation. -1 and 1 is my interval. Okay, so then I need to test my, I think it is my, oops, that's not my interval, I've just had my radius so far. I need to test my endpoints. So I'm going to test the -1 endpoint in here. So I'm going to test x equals -1, plugging that in to my f of x, n equals 0 to infinity. I get -1 to the power 2n plus 2 times -1 to the 2n plus 1. Okay, this, if I let this limit go to infinity, well, this is just going to end up being, looks like it's going to be 1 plus or minus 2. So this is always going to be a negative. Every term is going to be equal to -1. So it does not pass the nth term test, so this is divergent. Okay, so I've just tested the last term. The nth term is not gonna go to 0. It's just gonna be, every term is gonna be 1 minus 2, which is -1. So it's just gonna be -1, -1, -1. Testing so that just means it is less than. So I've got an open interval at -1. I'm going to test my other endpoint of 1. So test x equals 1. So I end up with 1 to the power 2n plus 2 times 1 to the power 2n plus 1. Basically, that's going to be equal to 3 as my nth term test. Again, it doesn't pass my nth term test, so it's divergent as well. Okay, so every term it's just going to be 3 plus 3 plus 3 plus 3. So 1 is also an open interval. So this is, my interval of convergence is from -1 to +1. Okay, so that's part A.